Hello and welcome. My name is Tim Neild, and this is my quantitative research into soil parameter investigations and foundation design within Rotorua, New Zealand. Attached is an academic poster highlighting the key information within this project. This presentation will explore the content displayed within this poster. Rotorua is a city located in the central North Island of New Zealand. Rotorua is situated in the northeastern section of the volcanic plateau within a large geothermal zone. Due to the large amount of volcanic and geothermal activity within this region, the subsoils within Rotorua have large variability, with many areas demonstrating soft soil zones. These inconsistent and soft soils can cause geotechnical hazards when designing and constructing residential, commercial, and industrial infrastructure within New Zealand. These geotechnical hazards can increase the cost of design and construction of foundations and may pose as health and safety risks. This investigation will aim to develop a preliminary foundation design that will support future residential, commercial, and industrial growth within the region. This research will assist design engineers with future geotechnical assessment, aiming to reduce the economical impact of geotechnical design and increase the safety of infrastructure within Rotorua. Foundations are structures that transmit load from a building, known as a superstructure, into underlying soil strata, known as a substructure. Foundations can be classified into either shallow or deep. Shallow foundations transmit load from the superstructure into near-surface strata. There are a range of types of shallow foundations, including footing foundations, which support the main structural columns within a building, and spread foundations, which distribute the superstructure load over a greater area. Deep foundations extend through weak, shallow soils into more compact subsoils at greater depths. These designs can either be bearing piles or friction piles. Bearing piles obtain the majority of their capacity from the bearing tip, whereas friction piles obtain the majority of their capacity from the friction between the shaft and the soil. At each of the 15 locations identified in high growth zones within Rotorua, the soil strength parameters will be analysed. These will be used to design a shallow foundation footing, a shallow raft foundation, and deep pile foundations for structural loads that are consistent of residential, commercial, and industrial case studies. This will be done using existing New Zealand Geotechnical Database NZGD investigation data, including CPT testing, boreholes, hand augers, and soil strength testing data available. This process includes initially processing raw geotechnical testing data within the site before estimating a site soil profile. This site soil profile is then used to develop a site cross-section. Soil strength parameters are then interpreted using Robertson 2015 Gregg drilling methods before conducting foundation design calculations and checks for each design load. The soil profile shows a medium dense to dense, clean to silty sand with occasional interbedding clay. This profile is consistent across multiple sites. The shallow soils achieved greater than 300 kilopascals and good ground based on NZS 3604, providing suitable soil for shallow foundations. This investigation highlighted that single and double-story residential and commercial buildings are recommended to be developed with shallow footing foundations, whilst industrial developments required pile foundations. Raft foundations produce adequate bearing capacity for all building types, but pose a large settlement risk within the area. Ground improvement can be used to mitigate this risk. High settlement is also shown in shallow footing design, with more specific design to monitor this. The soils in the northwestern suburbs of Rotorua are shown to be predominantly interbedded, loose to medium dense sands and soft to firm clays. However, the investigations within this area showed great variation. Additionally, localized peat beds were found. Shallow soils within this area do not consistently achieve 300 kilopascals, and therefore shallow footing foundations are not considered a likely foundation option. The Rotorua CBD and southern suburbs show interbedded loose to medium sands with soft clays. With many peat beds and large variation, these shallow subsoils do not consistently meet 300 kPa. However, further foundation design is yet to be carried out before finalising design recommendations within the northwestern suburbs and Rotorua CBD. Sites are likely to require pile foundations or geotechnical raft foundations with ground improvement available. These will be investigated in the coming weeks with results to support future development within Rotorua. Overall, my vision for the future of this research is to provide a public database via an app or a website that will inform public homeowners, land developers, or design engineers of the soils within a location. Using these resulted design recommendations, they will then be able to make preliminary informed decisions regarding foundations prior to the purchase of land or prior to specific geotechnical investigation. The overall goal of the future of this research is to bridge the gap between currently available NZGD and GIS mapping data and provide a publicly understandable database that can aid development within Rotorua in the future. Thank you.